into the second part, we'll talk about deeply about the reinforcement learning. Okay, so as we already know, like we need to let the agent do some action to the environment, and then the environment will send the state and the reward. The state and reward are two values, two data, so that help the agent understand whether it's good or bad. This is a data. They use the data to feed it back to the agent to know whether it's good or bad. Right? For the reinforcement learning, we have the idea like we have the formula kind of like PSA, which mean like the agent based on the state, they will give some action. For example, if we have the weather space, kind of like sunny or rainy, we have two weather state space, and in today we have two is a state space. This is the two possible action. Your action is kind of like play or stay. So today, whenever you see the sun outside, right, you say that, oh, I'll stay, I'll play. So sorry, I'll play. So it means that the P for the sunny is equal to play. Otherwise, whenever the weather is raining, you see it and you say like, oh, I'll stay. It means like the P of the rainy is equal to stay, right? So this knowledge, the knowledge in here is called the policy. Okay, so the policy is your decision function, right? Like whenever you see the state, you see the environment, your policy function is the one who determine your action, right? So it's kind of like in the game, like whenever in a Mario game, like whenever you see the monster, at the first glance you would not know whether the monster is good or bad. You touch him and then you die, and then you know like, oh, the monster is bad. Maybe the next time we won't touch that monster, right? No monster touching, like that. So this knowledge is the policy based on your interaction to the environment. This is interaction, the action to the environment, and this is receive the reward, and based on reward you fix your policy. Okay, so our goal is to like everyone has their own policy, right? And our goal is to like find the optimal policy so that this piece will always help us winning the game, right? So that's the goal. Okay, so let's deep dive a little bit into the definition. The first is about the space, the observation, which means like whenever we play, sometimes we could see a whole observation like this. For example, if it's chess, we could see a whole observation in here, right? Which we call the states because we see all of them, so that's why we call the states. But on the other hand, like this game, kind of game, for example Mario, when we show just part of the game, maybe there's a monster in here, maybe there's a reward in here, but we don't know because they being hidden by the screen limitation. So in this one we call it the observation. Okay, for the action space, sometimes the character they only have for possible action like up, down, left, and right. But sometimes whenever, for example, if you drag a motor, there's infinite possible action like 1 degree, 2 degree, 3 degree, to turn left or turn right, right? So we just got a continuous pace. Okay, so into the reward. So how can we know is it the reward good or bad? We couldn't know. Like for example, if we like chess, right? We move this item onto one step ahead. We don't know is it good or bad, right? Even though maybe your item will kill the enemy, kind of like that, but overall this could lead you into really bad situation. So we don't know whether this movement, this action, give the good or bad reward. We don't even know, except that we play until the end. So that's why we have the concept of like expected reward, which means like whenever we do the stuff, we need to calculate the reward from. We need to play until the end, yeah, to get the reward. We play it based on policy. The policy what we determined above. Yeah, if we know whether the step is good or bad, we need to play a whole game until the game end, so that we could know whether the policy, the reward is good or bad. So it, but the game they have two kind of game style. The first is like limited game style, which means like, for example, if we play the tic-tac-toe, we could play it until the end, right? But for example, this one is called the terminal state. But on the other hand, if we do some kind of graph, like a limited graph, we could know this task will continue forever. This has no terminal state. So that's why we need to have the we need to cut it into the episode, so that we could have the terminal in here. For every episode we have the terminal. Okay, so for the policy here, if we play based on the policy only, there's gonna be a problem. Like we're gonna strictly follow the policy without finding another better optimization. For example, if you go to some kind of vacation, like you go for traveling, you don't know any of the restaurant and you want to try, right? You see this one is good, so which means like the policy leads you into this one, so that the next time whenever you pick, you always pick this one without trying yourself to choose the other one, which may lead into more optimal result. So that's why they have some kind of item which called the epsilon. Yeah, which means like the epsilon, if for example if it's 0.5, it means like 50% chance we will follow the policy and 50% chance we won't follow it, but we explore it in random. Yeah, it's the epsilon. Okay, and on reinforcement learning, we try to decrease the epsilon in here. For the training time, we decrease the epsilon into some kind of level and we stay at it. It's kind of like the first time when we travel, we don't know about any restaurant, right? So we need to explore more. But for a specific time when we already well know about a good restaurant in this area, we just less exploration but more into the exploitation. We more to exploit onto the best restaurant that we know. But sometimes just a little bit epsilon race we will accept ourselves to explore, but just a little bit race. If it's too much, that's gonna ruin our policy.